This video is for problem number 7, and this is probably the most difficult problem, or most confusing anyway. We've got this industrial plant with two machines of type A and B, and a variable t for the number of hours of operation. And we've got two random variables, y1 and y2, applying respectively to machine A and to machine B. And we've got specifications for the mean and variance of these two variables, y1 and y2. And then we have equations for the operating costs of each machine. And what I want you to notice is that in both cases, the operating cost for A and the operating cost for B, the costs are dependent upon the square of the variable. So, 30y1 squared, 30y2 squared. So when we're asked to minimize the expected daily cost, what we want to find is what's the expected value of each of the two variables y1 and y2 squared. Let me say that again. We want to find the expected value of the squares of the variables y1 and y2, which is not the same thing again as the expected values of variables and then that squared, right? The square of the expected values of the variables. So because these two equations are dependent upon the square of the value, square of the variable, we want to know the expected value of the square of the variable. So for some reason in the solutions I missed a page or something, so I have the solution redone here for you. So for machine A, I've written down the information here. The expected value of y1 is 0.1t, as is the variance, right? Now I said we need to know the expected value of the square of the variable, but they don't tell us that. Fortunately, we remember our little formula, right, that the variance of a variable is equal to the expected value of the square of the variable minus the square of the expected value of the variable. And so we can solve for what we're looking for. We can solve for this expected value of the square of the variable. And so when we do that, we get that the expected value of the square of the variable is equal to the variance plus the square of the expected value of the variable. And so just filling in the information that was given to us, we can see that the expected value of the square of y1 is 1/100th t squared plus 1/10th t. Likewise, we can do the same thing for machine B and find that the expected value of the square of y2 is 0.0144 t squared plus 0.12 t. Well, that's great. Now that we have those two expressions for the expected values of the squares of the variables, we can move on to finding the expected daily cost. And so we look at the equations for those expected daily costs, and we see that the cost of machine A is 10t plus 30 times, and instead of y1 squared, we want to use the expected value of y1 squared. So that's what we have here, and the same thing for machine B. And so we've got two parts, A and B, where we've got 10 hours and 20 hours, and we want to see which machine minimizes the cost in each of those situations. So for 10 hours, we're just plugging in 10 for T, and when we do that, we see that machine A costs $160, or the expected cost for machine A for 10 hours is $160. The expected cost for machine B is $159.2, assuming I did my arithmetic correctly. Machine B would be slightly less expensive. At least we'd expect it to be slightly less expensive. For 20 hours, however, it turns out that we would expect machine A to be slightly less expensive than machine B. Again, just filling in 20 for T in all of the expressions, right? So in here in the 10T and 8T respectively, and then also in the expressions for the expected values for y1 squared and y2 squared above. Okay, so hopefully that makes sense. And again, ask me any questions tomorrow if you need to, and that's that.